DeepSeek has a cheap, powerful new model, and the AI sky is falling. The stock market is collapsing. The US tech sector is wrecked. Or is it? Doom and gloom was the reaction when DeepSeek, an AI company from China, shocked the world with a powerful new model. But now that we're catching our breath, folks are realizing this could be a massively positive, bullish development for the AI landscape in the world at large. We'll be exploring all of that and more on today's episode of AI Curious. My name is Jeff Wilser. I'm a journalist, I'm a human, and I'm curious about AI. You could argue that DeepSeek's new model, called R1, once again, AI companies are terrible at naming AI products. R1 is the biggest AI news story since the launch of ChatGPT. By now, you've probably heard the basics, and it seemed to come out of nowhere from a startup in China, and that crucially, this R1 model was built without the cutting-edge, high-powered chips for Nvidia that OpenAI and the rest of big tech needs. This meant that DeepSeek could build it for a fraction of the cost. This shocked the world, with some calling it a Sputnik moment. So I wanted to do a bit of a deep dive into DeepSeek. What does it all mean? What exactly is DeepSeek building? What's the implication for the AI space? And for that, I am delighted to have on the show an incredibly smart and respected thought leader in the AI space, Dr. Stephen Waterhouse. His friends call him Seven, who has been in the AI space since the 90s when he worked on AI for his PhD. Seven is a founder, investor, and most recently, the co-founder of Nazare, a VC firm that focuses on AI infrastructure. Most importantly, he's a really sharp guy who has a good take on DeepSeek. We start with a primer on what it is they built, what's under the hood, and what makes it qualitatively different from the way that OpenAI and Anthropic have been churning out their models. And then what it means for the wider AI landscape. Ultimately, Seven's take is bullish, even hopeful. The punchline for me is the team at DeepSeek showed that true innovation in AI still matters. You can do more with less, and that can make the building of AI more democratic, more inclusive, and it could lead to more exciting breakthroughs in the future. And maybe these breakthroughs don't have to come from billionaires and the big tech giants. I actually came away from our chat feeling a bit better about the world. I hope you do too. So with that, please enjoy my conversation with Dr. Stephen Waterhouse, aka Seven, co-founder of Nazare. Seven, welcome to AI Curious.
Hey, how are you?
So let's jump right into it with a primer on DeepSeek. I think a lot of listeners have heard that it's a cheap model, it's fast, efficient, and people are scared. And obviously the markets got shook up. Tell us about DeepSeek, kind of what this model is, how it's different, and then we'll get into the details of what the implications of that are.
Yeah, sure. So there's a couple of interesting things that DeepSeek brought in. So there are two things that have been done before, and then one thing that's new. And the sort of combination of them is the unique part of it. The first is a framework called mixtures of experts, which people start thinking about agents and various things like that when they hear that phrase, but it has less to do with that. What mixtures of experts does is it learns how to switch on and off sections of the network that you're using, essentially the weights, which are the sort of brain of the neural network, the family of neural networks that are in there. So at any point in time, intuitively, you might think like this. If I see a math problem, I turn on my math experts. If I see like a poetry problem, I turn on. It's actually much weirder than that. And there's been some analysis around what the mixtures of experts actually learn. And it can be actually very different, sort of more weird than we think. But that's the intuitive side of thinking about it. And in addition, you then have another network, which is learning how to switch between those different parts of the overall network. Now, okay, so what? Well, so what is that you can massively reduce the amount of weights that are used in the network from billions down to even less than billions. To at any one point in time, you're using a much smaller set of the network. And that also applies during training. So your training can be more efficient and your execution can be more efficient. The second thing that was done, and that however was, I mean,
Just to make sure, just to kind of be silly with this.
yep,
So the idea that like in a traditional LLM training
hmm
model by
yeah,
OpenAI, all of the quote unquote experts, like the entire, if
hmm
there's a massive data
the
set,
entire network, yeah,
the
hmm
entire compute is being harnessed at all times, whether the problem is in math or poetry.
well,
And this is are able to only use relevance
hmm
parts of the model. I mean, get here already a little
it's
fuzzy
a
on
bit
is
it's a
it?
bit like the way
Yeah,
your brain works. Your brain
yeah.
actually, it's not like sections. It's like, overall surfaces, and different connectivity is used in different times. You have this expression like left brain, right brain for
Sure.
analytical or creative reasoning. It's the same kind of idea. Now, the answer to your question is yes and no. Now, ChatGPT and OpenAI also uses mixture of experts, and I think that Mixtral, which is a French-based company, Paris-based
Hmm.
company, was perhaps the first company to use this. The technique itself dates back in its earliest forms to the 90s. I did my PhD on mixture of experts, and then was introduced in the concept of how to select parts of a large network, I think by Jeff Hinton, maybe 10 years ago. So it's not new,
Hmm.
but it was used very aggressively in this model, and
Okay.
highlighted as one of the efficiency mechanisms. The second mechanism was the use of quantization. So what that means is that instead of representing the weight as a full floating point number, you essentially represent it as a smaller set of numbers. So the way to think about this is, instead of having like, your number with like this extremely long decimal point after it, you just kind of truncate it back, right? You just imagine you just
Hmm.
try making it smaller. So they use
Sorry,
a form of
sorry. What was the word? What was the word again? Say it one more time, please.
truncation, or the
Truncation.
quantization
Okay,
as the,
got it.
but the
Is it?
quantization is the expression. If you were to search the internet today and look for quantization of neural network weights for training and execution, you'll find hundreds of papers. It's a technique that's been used all the way back into the 90s as an efficiency mechanism. Certainly when I was doing my PhD in this area, you had to be efficient because we didn't have as much computing as we have
Yeah.
now. And today you have to be efficient because it's so expensive. So you have to like
That reminds
really
me,
focus on
and
that.
I could be way off. That reminds me from way back when, from like high school science, there was a concept of significant digits, right? And
Mhm.
when you're doing an experiment, at times it's matters to go out to 5.47263. And at
Yeah.
times 5.5 is kind of all you need. And actually, at some point,
Right.
there's like a false accuracy. You actually don't have, at some point after the fifth digit, you're kind of making things
Yeah, it
up
doesn't make
anyway,
sense.
right?
Now, this gets complicated when you're multiplying numbers together multiple times across. So
Hmm.
neural network training and is a form of like matrix multiplication. You're just going back and forth and back and forth. You've got billions of these things. So imagine you then start truncating them. Well, the accuracy and the behavior of the system is going to change. But if you do it during training, you can actually learn how to sort of handle truncation. So
Okay.
um,
Okay. So there are two. So far we covered
there's
two.
two techniques that have been used before. Now the final technique, which is also like it's like a part of the literature, which is a technique called reinforcement learning. Now, reinforcement learning, there are really three kinds of learning in sort of regular machine learning. There's supervised, which is, here's a dog, here's a cat, here's a picture of dog, here's a picture of cat,
Mhm.
here's 1,000 pictures of a dog, here's 1,000 pictures of a cat. Now you know how to sort of test
Right.
between whether a dog and a cat is the thing. Um, and then there's unsupervised learning, which is, it's technically really the way that transformers are built
Yep.
today, which is you sort of have this thing where you feed the text in. It's almost like a time series prediction. Essentially, it's like, well, I've got the answer here, which is, this is the set of words that are coming next after this one thing, so I can kind of predict what it is, and you sort of predict around. So it's like a form of unsupervised learning um, slash time series. And then the final one is reinforcement learning, and this is how children learn, right? So you kind of go, okay, try to walk, and have a small child, and they're trying to like, it's like this sort of controlled falling thing. It's like, like if I do this, then I walk, and if I
Hmm.
don't, I hit the ground, right? So you kind of like, through this process of trial and error. What's interesting about reinforcement learning, as an aside, is that the kind of thing is, there's basically like, the challenge is, how do you represent a value function to fit to? How do you say, what is the function by which I'm trying to learn to? Right? Because the outcome is very rare. Like
Hmm.
the sort of I managed to walk is rare. Now, what led to me walking? Like I don't know. There's all these random things I
Right.
did.
I
So
love
what
that
was it, right?
analogy. Yeah.
So there's a lot of research around this and very interesting literature talking about time delay and how you bring the value back sort of in time back to the different parts of the step that you've gone through. And it turns out that mapping is actually quite similar, if not very similar, to some of the mappings that actually happen in our own brains. So
Mm.
it may be that human learning is actually quite similar to the technical research level of reinforcement learning. So I'm glossing over many details here, but that's
Sure.
an interesting part of it. Um, and I'm not suggesting these things are alive and think, by the way. So that'd be another conversation. So,
Right.
so, so what's interesting with the reinforcement learning is that it seems like what happened with DeepSeek is that a form of kind of model distillation was done, essentially like taking the
Hmm.
output of a previous generation. I think people are saying it with ChatGPT 4. I'm not sure it was, but what it seems like they used a less sophisticated uh, or like larger model, maybe not less
Hmm.
sophisticated, a larger model of DeepSeek. And then by essentially feeding it questions and then looking at the answers, they were able to build up a reinforcement model around reasoning. So the problem with reasoning is
Hmm.
that we don't have lots of data about this on the internet or in the world, right? You don't sit down there and go, okay, right. I'm going to take this piece of data and I'm going to put it in the Google sheet, and then I'm going to pull my calculator out, and then I'm going to do this research over here.
Right.
Then I'm going to pull up.
We see
We
questions and answers, but we don't see the
we just
actual
yeah,
chain of
and
thought to get there. Right.
and this is one of the problems with, for example, cooperative agent architectures, where we don't have data on what people do. And one of the problems that has emerged with systems like Operator, which was made and browser based, which has made them hard to build, is that we don't have data. We've had to capture data about how people use computers.
Yeah. Yeah.
There's no like kind of other than YouTube videos where people are doing things and showing new demonstrations. We don't have like this collection of data about people and what they do. And then we certainly don't have data on reasoning. Now, what's really exciting about this is that um, we are suddenly realizing that we can develop data sets from other language models that demonstrate reasoning. And then we can train a system on that, which is what happened with the latest version of DeepSeek, which
Hmm.
is then substantially cheaper to train and execute on. Um, I'm not going to get into this, the without apart from just referencing it, there were definitely people saying, including Elon Musk, saying they faked it. They've actually got
Yeah.
H100s, et cetera, et
Can you
cetera.
actually just can you again with a
Yeah,
clear
I'll talk about
caveat?
it for a minute.
This is you. You are not endorsing these theories. I understand that
No, no,
this
no,
is not
no.
coming from you, but for listeners of this podcast who might be kind of sort of aware of some controversy and questions,
Yeah.
can you kind of give us kind of the main beats of this kind of
Well,
subplot?
and and and
So just to back up, the model release, it blows everyone away. Like, oh my god,
yeah,
how is it possible that something this good can be done
yeah,
for this cheaply? And holy shit, what does that mean for the chip makers? What does it mean for US AI companies? Oh my God, we're all freaking out.
yeah,
And then there are
exactly.
folks like, but wait a second, is
Yeah.
it possible they did this or this? Can you walk us through what kind of some of these conspiracies or theories are?
Yeah, so certainly a number of conspiracy theories came out. I don't know, they weren't really theories, they're just like very quick
Tweets.
tweets and then some
Didn't
long
even
some
rise to
long
the level of actual theory.
yeah.
More just,
So
yeah.
so just brain farts, right? It's like, oh, this doesn't make sense. And then there's this, and bear in mind, I spent 25 years living in San Francisco, so I kind of consider myself more Californian than English, even though the accent is sort of a hybrid. So when it came out, and I'm not being anti-American here, but the kind of the hegemonic thing came
Yeah.
up, and it's like, oh, how dare these Chinese people
Yeah.
dare
Yeah.
to challenge our
Yeah. Well, we're Americans.
intellectual.
Clearly, the best must come from the U.S. So
They
it
must have
must not
copied
be.
it. They
Yeah.
must
Yeah.
have copied it. But the thing is that they actually did something very interesting and very new and novel, and um, they may well have some H100s they're not supposed to have. I don't know.
Hmm.
They may most likely have a bunch of Nvidia chips that are not subject to the export issues, which ban
Well,
certain levels of chip.
sorry. Just to jump in quick for listeners who might not have been
Mm,
following every twist and turn, that it kind of there are at least two of these theories, right? And I'm sure I'm missing plenty of nuance
yeah,
here, but to summarize, one theory, because what was so striking about what DeepSeek did was they built this model that's competitive at the absolute like top levels against OpenAI's frontier model,
Yeah,
but using not using the same kind of high performance Nvidia chips OpenAI use, and like
exactly.
using chips that are
Hmm.
like. And so one theory was, wait a second, maybe they're kind of sandbagging, and they actually
Hmm.
had chips under the hood that they did not disclose. And maybe even there was, I think
Oh,
there was Elon's theory that like they actually smuggled like to get
yeah, yeah.
around bans and import export bans with China. That like chips were being, I don't know, people like
Smuggled
drug
across the
chip
border in
mules, going
suitcases. Yeah,
exactly,
exactly.
exactly, yeah.
Yeah, and
And that's what. Go ahead,
maybe
sorry.
this is true, maybe it's not.
Yeah.
The thing that and there was even a theory that the founder, who I think is still or previously was very involved in a hedge fund in Shanghai, he there's a theory that they shorted the market in order to take advantage of this, very
Mm-hmm.
sudden shock.
Mm-hmm.
Um, I don't know what I'm
Right.
interested in the
Yeah,
technological and
and
the
we'll get back to
future
yes, and
implications.
we'll get back to that
Yeah,
in one moment. Last little digression here is
yeah,
that other, and I think is relevant to tech, is other
mm,
concern slash theory slash brain fart is that
yeah,
whatever we were calling it is that the open it was the train the data sets, the
no,
inputs
yeah,
for
yeah,
DeepSeek
yeah.
was actually the open AI models, and they were
Well,
or Google models, and it was struck many as incredibly rich, that there were complaints with this, given obviously
yeah,
that open AI is now well documented the kind of gray
yeah,
area at best of how these models are trained in the first place against on data that is legally or
mhm,
illegally obtained. To them, he's saying, wait a second, you can't use our models for training your own models, is obviously quite
yeah,
rich. So
yeah.
thank you for, yeah.
It's a very ironic thing. There's
So
a lot of things there, and people
let's.
getting very excited and very upset and talking about putting in new rules and having bans on. I was the best one was that someone wanted to put a ban on the use of Chinese technology in America, and I'm like,
Oh my
can you
god.
can you spell Great Firewall? Because like you've been talking about how bad that thing is for a long time, and then all of a sudden you want to you want to do the same. I was like, okay, but trade wars are very du jour right now, so that's
Indeed. So I do want to pivot momentarily to the
mhm,
kind of implication of all this and kind of what it means for the
sure.
overall space. But before we go there, any other anything else that you want to cover about the actual tech? So we should probably mention the open source nature of it, right? And we'll kind of get
Oh
into
yeah.
yeah. So talk about kind of how what else distinguishes what DeepSeek did from the more traditional frontier models.
Well, I mean, there's a lot of details. I wouldn't do justice to kind of go into all of the aspects of it. What I will say, just to kind of follow up on the sort of the conspiracy theories, is that
Yeah.
they wrote a very detailed paper. They published, open source the models, and then they um, described very clearly how to do it. So much so that Berkeley researchers were then able to essentially recreate the same technique albeit
Hmm.
on a smaller data set, and start solving some, and building some language models quickly with very few resources. People managed to demonstrate its use on very small, very low-powered hardware that you wouldn't have expected the inference to
Hmm.
work on. So it was very quickly uh, essentially sort of proven that this was very unlikely to have been faked.
Yes.
There may well have been, um, uh, you know, other chips used in the development of the previous models, but to me, what was astounding was that the fund that I'm operating, one of our thesis, we're focused on an AI infrastructure. One of our thesis is that AI is too expensive to build. It's the reason that it's big tech and big AI, and many people in the crypto community and others worry about big AI being bad, right? Well, it's
Hmm.
like controlled by these people who can only a few people can afford to train a frontier model. So,
Right.
but um, the AI community and the literature has been around for so long. We have decades of research talking about how to make things more efficient. Currently, up until very recently, I guess up until last week, the belief was you could only build a frontier model using not just Nvidia H100s, but exactly the same chips. Like if you had some H200s and H100s, it doesn't really work because they have to be the same
Yeah.
one.
Yeah.
So this kind of sort of homogeneous design was very like antithetical to a lot of the experience I've had as an innovator and researcher, an investor, that really hardware is a very heterogeneous thing overall in the end. Is that essentially the software tends to route around homogeneity and find ways to work
Hmm.
with other things. And people innovate in ways that you can use a chip from these guys and a chip from those guys and an older chip and a newer chip and a slightly slower bandwidth and a slightly faster bandwidth. Um, in the early 2000s, I sold a company to Sun Microsystems. And while I was there, we were working on developing storage systems and search systems using not proprietary, sorry, non-proprietary, as in like
Open, right.
commodity hardware,
Hmm.
and then open source software. And this was completely counter to, so we were a skunk's work. We were like trying to like do something different, which actually became a product. But this was very counter to the sort of .com from Sun Microsystems, which is the tagline during the .com boom, to have proprietary hardware, these very big servers, and then their own software. So NVIDIA, in a sense, is somewhat similar in the sense that it's been pushing this very, very high-end, small set of like customers that are just buying more and more of these very high-end chips. And
Hmm.
along comes this Chinese startup out of nowhere and says, "Hey, we did it on a bunch of consumer-grade gaming chips." And everyone's
Yeah.
like,
And some duct tape, right?
"No,
Right.
like
Right.
this
Right.
can't be
So
true."
so let's talk about what that could mean. What do you think are there? I imagine a ton of implications both
Yeah.
on the tech front and then the wider industry fronts, and
Mm.
then potentially the stock market front, but even like how AI can impact the world, right? So what, like
Yeah.
when the market first freaked out, my naive
I think it
layperson
was down
thought
like 20% on Nvidia, was
on
that
Nvidia,
on the
right?
first
It's
day?
like 17,
Yeah.
20 Nvidia, and then
Yeah.
the Nasdaq 3%, S&P
Yeah.
2%, right? I I
It was like
understand.
it was like a good old crypto correction. It wasn't
Yeah, it
just
was.
like
It
a,
was like
yeah.
that was like a Tuesday in crypto world, right? That was.
So I was like,
That's,
whatever.
yeah, Bitcoin holders like, well, whatever. That's Tuesday.
So
But
yeah.
what I did, what I here's, I got part of that, but didn't get other part of it. What made sense to me was that Nvidia taking a hit. Sure, that made sense. If it turns out you do not need, to your point, this
Mm.
homogenous high end Nvidia chips, it makes sense they are hurt. But to the extent that Wall Street is baking in AI bullishness for the future, and that will be kind of
Hmm.
that could be a reason, some tailwinds for companies to be more profitable. I would think it doesn't matter whether that AI comes from open AI that's pricier or to some DeepSeek that's cheaper. What
Mm.
matters, if I'm a company that's making widgets, I care about if there's an AI solution that helps me lower costs or do things more quickly to increase
Mm.
my profits. That's
Mm.
the important
Yeah.
thing. Who cares? So actually, I would think that most of a stock market outside of the chip makers themselves, there should be good
Mm.
news. I would think, oh,
Hmm.
cool, there's lower priced AI on the horizon, and it might keep
Hmm.
getting better and better for cheaper. What was your take on how it impacts the
So
market? And
so
yeah.
you're employing system two thinking in the AI kind of issue. It's a slower, more careful, more reasoned. Whereas stock markets work on system one thinking, which is just
Okay,
instinctive, like, oh my
fair.
God, freak out, quick. So um, I, I
Well,
um a great quote by Chris Dixon, who's an old friend and investor
mhm.
in one of my last projects, and he put it like this: someone was asking him, like, what do you think about Sol and Ethereum and what goes up and what goes down? And he's like, in the end, what I care about is people building applications that billions of people use.
Yeah,
And
yeah.
that's the same with AI, right? Does it matter whether we have NVIDIA or someone else? Does it matter whether it's the highest end chips or lower end chips? If you can do more with what we have, that's
Right,
amazing, right? If
right.
you can build even more intelligent systems, then maybe the bottleneck is actually the data, which is what a lot of people are saying. Or maybe the
Hmm.
bottleneck is like, have we explored the full potential of models and algorithms, which is part of what I've been saying for a while. So just
Hmm.
it is the more we can do, and I think that's the exciting part of this development. The other exciting part is that we can increase the access, the democratization of this
Yeah.
technology, which Arguably in the modern world, the current contemporary world, started with the leaking of Llama from Facebook, which I'm pretty sure was not a leak. I
Mm-hmm.
think it was actually a strategic move.
Hmm.
And and that one that's really led to this explosion of open source developers in mostly the inference and model execution and agents and so on. But if you can innovate on the training aspect, which up until now only a few people were trying to do, and those were like Noose Research and Prime Intellect and Jensen working on decentralized training
Hmm.
algorithms.
Hmm.
If suddenly you can do these things with DeepSeek style systems and it's much cheaper, and you can use the deepins, the GPUs, the guys like
Hmm.
Vast who are an investor, and there's just like collection of gaming hardware. That's what it is, like high-end gaming
It's
hardware.
funny. I've spoken to Ben Fielding at Jensen multiple times.
Yeah,
Super, super smart, sharp, great guy.
yeah,
And I've stuck at length with him about the challenges of deepen and trying to decentralize
yeah,
training. I hadn't even thought about this suggests there is more innovation possible than we thought with training.
yeah,
Because I think like to back up one level, it seemed like for a while, okay, it's really about grinding. There's like two main variables. There's for LLMs, there's compute and there's data. And it's kind of this arms race of who can get the most compute, who can get the
yeah.
most data. And we just kind of pump in the data, compute, 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 and that
Mhm.
hopefully will build better AI. So to synthesize what you're saying, I think, is like the cool thing here, as you mentioned, lots of details, lots of nuance, but essentially there was innovation in DeepSeek in ways we have
Yeah,
not quite
innovation in the
seen.
model, innovation in the algorithm, and that this is counter to the Rich Sutton's he calls it the bitter lesson, which is that it's a great quote where he says that the bitter lesson is that after decades of research in this area, what we realize is that all that really matters, as I'm paraphrasing, is tons of compute and tons of
Yeah.
data,
Yeah.
and um, and these guys have shown that that scaling law, which does seem to be holding very much like Moore's law, which is
Mm-hmm.
another law that people often wonder is going to run out, actually gets to the next level, not through some linear function, but often through a step change. And the step change is
Mm-hmm.
you change, you figure out something new in chip design, you figure out something new in
Mm-hmm.
materials, or you figure out something new in models and algorithms and so on. So imagine, I had actually, Jesus Rodriguez wrote a
Mm-hmm.
great piece recently for CoinDesk talking about DeepSeek and the opportunities for Web3 AI, and one of them is the idea of decentralized distillation. So being able to run other models that are then creating data sets for other models to then consume, so that there's a lot more opportunities to decentralize these things and sort of segment the workloads versus just the work, like as I said, Noose Research and Prime Intellect done on the decentralized training ideas. That's one
Mm-hmm.
approach, and then there's I think a lot of other opportunities there. um, I look at the deep in space and in general as like it's just a big sea of computation,
Yeah.
and to the extent that you can use that and find opportunities within that, I think that there'll be great results there.
Let, let's talk a bit more about the open sourcedness of it all. I think you touched
Mhm.
upon that earlier. You mentioned that when there were these conspiracy theories, the fact that it was created in this open source way let people just like, hey, cool, you can like here I'm showing my work, I am showing the proof, showing my homework. You can test it out yourself. And when people did that and took kind of parts of the code, I'm not speaking accurately here, but not necessarily code, but they were able to get the same results. What do you think this DeepSeek's success means for um, the future of open built AI models? And do you think it's kind of like, is it going to nudge us to a more open direction? And then more broadly, how are you thinking about the kind of debate between open and closed in the AI worlds, right? Because the kind of classic, and I'm going to try and briefly summarize for listeners, the classic trade-off is um, that an open source solution hopefully brings more innovation, kind of a marketplace of ideas. People are able to kind of the transparency helps people iterate faster. The downside is or upside, depending on how you look at it, is there's less control. And if in a world of, if the classic kind of concern is someone could learn how to make nuclear weapons or biochemical
Mhm.
weapons in an open source world when there's no kind of guardrails and stuff.
Yeah.
I
So
know
the one
it's a
cat,
long-winded question, but how are you thinking
yeah,
about
yeah.
all of that?
The one caveat here is that um, I think one of my previous co-founders was a guy called Brian Fox from who wrote Bash and Emacs, and he's real open source. So open source is really technically defined as you get all the code. So in an open
Mm-hmm.
source AI system, a real one, you'd get here's the training data, here's the code you can compile, here's how you compile the code for different
Yeah.
kinds of platforms. Here's how you execute it, right? Here's the configuration. That's a full open source specification. This, in common with Llama and all the other ones, is an open weights. So you get the weights
Mm-hmm.
and you tell you how to configure it. You can go like plug it into Hugging Face or one of these models and say, okay, run this thing. So it's open weights. It's not open source, but you do
Mm-hmm.
get the weights. And in the case
Mm-hmm.
of ChatGPT, you don't get the weights. It's closed. It's a
Right.
black box, right? So having said that with one caveat, so and there are other companies working on, and some of the projects I mentioned before are actually working on open source training models,
Mm-hmm.
which would
Mm-hmm.
be very different. And that's where I think the innovation around you know, different people developing new training algorithms, which will be this explosion, like an Apache moment for this space. I mean, Apache
Mm.
being the first open source web server. So um, to your question about safety, yeah, and then this model has failed, I believe, the standard safety test that people run on how easy it is to exploit is the most exploitable, most jailbreakable
Oh
system.
yeah.
They have not optimized it for that. If you want another conspiracy theory, I'm not sure anyone's been running, but I'll start one, which is that this actually was planted in order to freak out
I
Western
love it.
governments and
I
societies.
I love it.
In the same way, by the way, in the same way that I believe that there's a high likelihood that the whole sort of Chinese Tiananmen Square situation, which you're not supposed to talk about, but I think there's a high likelihood that that kind of censorship will probably be a thing of the past soon because, I just give you a disk with this is the model, or the model's available here. I can get to it on a VPN. It's hard to
Yeah.
to factor for that. You're compressing the internet effectively. And what's interesting is if you look through DeepSeek and try to prompt it for things it's not supposed to talk about, it even says in its thinking process, "Oh, I'm not supposed to talk about this. Let's make sure that the user's
Oops.
not talking about that thing that I'm not supposed to talk about again. That happened in Tiananmen Square during the spirit." It
Right.
like tells you what it's doing, right? Because it's not it's been trained and then it's got a guardrail model on top of it, which is checking what its output is and then filtering it, and then it just shuts down.
And so I'll
Uh,
literally just to kind of underline that. So it could be literally say, well, I am not supposed to tell you how to build a
Pretty
nuclear
much.
bomb.
And
Here are the
people,
37 steps I should not be telling you. Like that's the kind of thing you can do in open source models. I'm exaggerating a bit, but not too
well,
much.
yeah. So, like, I'll just, I'm plugging a few companies that I'm part of and figuring those are not, but there's another company called Layer Lens, which is on benchmarking, and we've also been looking at safety benchmarks, essentially, like, what is it? How do you benchmark these systems? And that area is fascinating because the when you look into the jailbreaking space and how there are databases of prompts that get you access to latest models, and this database is changing all the time. And it's not put on the deep web somewhere. It's like it's actually you can go get these things and go try them out. Not everybody goes around doing this all day long, but you can prompt OpenAI system. OpenAI is the safest. They put the most effort and money into jailbreak, making it
Hmm.
jailbreak proof. But you can still do it, and they're playing this kind of cat and mouse game to stop it from jailbreaking out. So as far as like safety goes, yeah, I think it's very challenging, right? It's very different to being able to search for information about how to, make something toxic or build something dangerous, um, and then try and put those pieces together versus, running like deep research, which is this new thing from OpenAI, which is astounding, by the way.
Hmm.
What was interesting
Hmm.
also about the response to DeepSeek was that all of a sudden, both Google and OpenAI suddenly released their very next generation models,
Oh, it's time to
which
ship. It's
completely blew things. I was just like, okay, fine.
yeah.
I'm actually blown away at this point. And if you ran like a deep research query, which is the whole nother story, but just imagine a very, very sophisticated research program, on how to do something and there was no guardrails and it just gave it to you, I have no
Yeah.
doubt that that would give you a very detailed idea of how to do something. Maybe then order you the parts, maybe get them shipped to
Right. Right.
a mailbox that it obfuscates and so on. So just let your science fiction fantasies run because really that world is here. It's
Yeah. I
very,
mean,
very
and
much
like
here.
the count, like the classic argument, the pro open argument regards to safety is, hey, it's already out there. If you want to build a
Yeah.
chemical weapon, if you look hard enough on the internet, you could find it. That's quite
Hmm.
different to your point from me saying, start even smaller, right? What's now with agents to say, hey, I want to do a really bad thing. Please help me do that
Mm.
as simply and quickly as
No.
possible, right? That is
So
going to democratize, or as
yeah,
the risk of democratizing really
and
bad things happening.
so I was going to say I'm going to put a different hat on, but I'm going to change my glasses because they're a bit dirty. But I'm going to take off my investor hat and I'm
Uh
going to
huh.
put on my like founder hat. So you may know, like back in 2017, I started a company called Orchid, which is about
Mm-hmm.
decentralized VPNs, essentially about open access to the internet and censorship resistance and freedom of information. And the calculation you make when you're building systems that are focused around privacy is that what you're saying is it's better to have an open system in spite of the dangers, because that's better than a totalitarian system controlled by, different state powers or
Mm-hmm.
companies
Mm-hmm.
with full surveillance of everything you do and all of the um, abuses that can go with that, and also the potential with the internet and AI, of course, then to build a system of perfect control, which you can't really ever get out of. Right? That's a 1984 some model, Brave New World kind of models. These kind of
Mm-hmm.
systems, the Matrix. Pick your science fiction nightmare. Um, and I would argue that the same holds true for these open weights and open source AI, which is that I believe that the world is a much more dangerous place when we have totalitarian control of AI systems, very, very powerful AI systems that are controlled just by a few people, than the dangers that are clearly inherent in
Mm-hmm.
having free access to open source systems and open weight systems. Um, and then similarly, there's another argument around sort of AI acceleration or otherwise, but that's a separate topic. We can we
Okay,
can go into
so
that later.
uh, well, I actually love getting back to. I mean, I think to summarize, I think um, it's fair to say at the very least that in the kind of like tension between an open source fueled AI architecture and more closed, what DeepSeek did was really strike a blow for the open worlds, the open model worlds. And whether that's, again, there's pros and cons there. People can debate the safety implications, but there's definitely a surge of energy in the open framework. What are your predictions, Seven, on how this DeepSeek kind of bombshell? How do you think this is going to impact the AI space next, let's say, if next year, next 5 years? Give us a prediction or two of how you think this might change what types of products we'll see,
Yeah.
or how
Well,
companies will progress. Where's this all heading?
I think we will see, and what I'm hoping is that we will see a sort of a kind of like I don't know, a model kind of spring period where or an algorithm spring period where we see a lot more people saying, hey, you know what, I'm going to start a company that we're going to focus on building a more advanced model. We're going to use this kind of new idea that we've turned out that these guys at DeepSeek did, because it turns out we can build this thing for much less. All I need to do is go raise 5 mil or 10 mil for the
Mm,
hardware, and then I can have a crack at this versus like, I need to raise 3 billion, which was XAI,
right,
right?
right, right.
So if you can suddenly do that, it's this Cambrian explosion of lots of different kinds of ideas, right? People will dust off all research papers and find something. And please, like if you are doing this, get in touch with me. I will invest in these areas. So I'm hoping this is true. But what seems likely is
Listeners,
that
he's
this
trying to give you money. He is, if you have a startup, he is trying
yeah,
to give you money.
this area I'm obsessed with, and I think then what we'll see is that in a couple of years' time, after like many people try this, a few people will succeed, and we'll see some different architectures. And we already have some different architectures. We have DeepSeek. Before that, we had Mixtral. We had Liquid AI. There's other people tried different approaches, but mostly it's been the same thing. I wrote a recent article in my Substack where I called it the Tower of Babel, which is like the Tower of Babel from the Bible is people just trying to build this one tower going up to so we get to God, right? And that's kind of like OpenAI is that we're trying to find God. It doesn't matter how much money we invest to get there. Once we get there, we've got God. Like so, it's like the return on investment is infinite. But in fact, you can build a lot of other towers, a lot of other buildings, a lot of other systems. You can invest in lots of different things because there's a lot of the opportunity space. Then we focus very much on the very earliest stages of the company and on fundamental technologies. And I'm confident, and we're already seeing things that people will start innovating in that area. Beyond that, and what are the knock-on effects? The world, it's just like the crypto space has like investments in infrastructure, and then we get some apps, and then people figure out, oh, actually, I need some other kind of infrastructure for this. I need to be really fast things to do that. So that new wave of infrastructure, which is lower cost, more distributed, more democratized, whether it's crypto decentralized or just lots of people doing it in that sense, will, I believe, lead to lots more innovative apps. And so apps that are easier to use, apps that are more accessible to people, apps that are lower cost. Some apps that will end up being just on your device. So you turn everything off. It's still working on the plane, for example, in airplane mode, more compact, more compressed, these kind of things, which then it goes beyond a system that you're talking to and doing things. It's something that's like in devices. I think that the sort of Internet of Things and the kind of more like we call it embodied AI, whether it's full-fledged robots through to just systems that are actually intelligent. IoT had this weird sort of false start where we started building it and then we're like, actually, everything's just really dumb. Like, that's not that fun. Like, and there's these
We don't need a refrigerator that connects to the internet. How useful is that?
But it's like, it's like, it's better that the refrigerator is just smart, not connected to the internet. It's like, don't eat that. That's off. You're going to get really sick. Like, that'd be kind of cool. The refrigerator that told me what not to eat, or hey, you really shouldn't eat that. You told me you're on a diet and like trying to cut down on sugar, and that's actually got added sugar. Did you know that? I mean, it might be annoying, but some people would like that, right?
I'm envisioning actually that a steel trap goes. You cannot get these cookies.
But these kind of things. My parents are getting older, and I think about that we want the system that actually takes care of us when we're older, right? We want systems that like that nurture us in different ways, and these systems are not going to be, I don't think, some big large system even connected to a phone. I think they're probably going to systems that just hang out in the house and don't need to be connected and just work.
Connecting back to DeepSeek, and just to kind of, because we can wind down here, if I hear you right, this is actually a fairly bullish development in a sense that this is a sign of true innovation, not just pumping in more compute, more data. They did a lot more with less, which gives others in the AI space hope you can also do more with less. That could bring prices down, that brings innovation up, and that will ultimately lead to better applications and solutions for all of us, and hopefully let other parts of the world too, that non-billionaires, there could be developers and some literally thousands of miles away, they could do something cool in their garage that might not have been possible in kind of a billionaire's open AI model.
And I think that it's really important to remember that in any engineering, science, technology development, it's not like, we hear about sort of AlphaGo and the guys from, Google and the guys from IBM, and then OpenAI, and we kind of tend to sort of embellish these people as being like, oh, they're the ones that figured it out, or that, there's this one person that figured something out. But really, they stand on the shoulders of giants. They stand on like a large community of people that are working on these ideas. And if your infrastructure becomes cheaper and more widespread, those people can go off and build these interesting things and do experiments on things and develop things that will then lead to crazy new ideas and crazy new opportunities. And that, I think, is much more interesting than and much more powerful, and ultimately much more successful than one or two companies harvesting everything, all the people, all the data, all the compute. Call it good or bad. It's just not as productive, right?
Seven, that's a great, hopeful note to end on. Love it. Thank you so much for demystifying this pretty complex topic. Really enjoyed it. Thanks again.
Thank you, John.
Well, there you have it. Thanks again to Dr. Stephen Waterhouse. And thank you to you, dear listener. Hope you enjoyed. If this is your first time at AI Curious, please give it 5 stars, subscribe, send to a friend. Thanks again, and see you next time.